Hello and welcome back to this Walking Talking Mock. Bit of a technical difficulty. I just filmed part 2 of this. This is Further Maths 2014. Yeah, I filmed part 2 just now, and it won't let me transfer the file off this iPad onto my computer. It says that the file doesn't exist. It clearly does exist. So I don't know if I'll be able to find that. But anyway, here's part 3. Everyone knows that part 2 is always the worst of any film series, right? Is that true? Not really. The Hunger Games part 2 was pretty good. The second film. Second book of the Hunger Games is definitely my favourite anyway. Anyway, so we're on question 17. You might have missed questions 9 to 16, but oh well. Factorise this fully. Okay, I can do that. I can see that there's a common factor of d. I can also see that there's a common factor of 3. So I'm going to be left with 4c squared minus 3d. And can I factorise? I can't factorise that bit any further. It's not a difference of 2 squares. So it would just be that. That seems a little bit simple. I don't know, did I do that wrong? No, that's fine. Okay. Factorise this fully. Okay, this one's the harder one. Right, in the mock exam that we just did in maths, there was a question very similar to this, and what you guys did was you expanded it all out, and then you were like, wait, the question said factorise. That's the opposite of expanding. So some of you managed to factorise it back to how it was in the beginning, which was a bit pointless. You don't want to expand this. You need to spot the common factor. What is a common factor here? W plus 4, W plus 4. They are common factors. There's a W plus 4 there, there's a W plus 4 there. It's common. So we take the W plus 4 as our common factor. We take that outside. What's left? Here I've got a W plus 4 squared left. And here I've got, squared, okay, W plus 4 squared is common actually. So let's make that W plus 4, okay. And here I have none of those, I just have a W plus 1. Like that. Those brackets are important, by the way, because otherwise I might not realise that I need to minus this one as well. So to simplify, W take away W is nothing. 4 take away 1 is 3. Okay, so it's just 3 W plus 4 squared. Ended up very simple and nice. That was from the previous question. 18. ABCDFGH is a cuboid. Work out the angle between EC and ABCD. EC is here. Okay, so as always, when we're thinking about 3D trigonometry, when we want the angle between a line and a plane, we have to always think about finding the angle between a line and the shadow of the line on the floor. Okay, this pen is the shadow, this is the line, and it will be directly underneath it. Okay, like that, because the sun, you have to imagine, is directly above. So it's the angle between, it's not between, because if you're thinking of just, this is the plane, right? The angle between a line and a plane, you could think of it as like that way, or 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 that way. There's like infinitely many ways you can measure that. So you need to just think about between the line and the shadow of the line on the plane. And there's only one way for that to be. Okay, and they've actually drawn us the shadow of EC, which is AC. So that's the angle we're trying to find. Okay, so let's see, we've got the opposite length here. We don't have this length, but we can work this length out. So let's work that out. So A to C, by Pythagoras, it's going to be the square root of 8 squared plus 14 squared, which is 60 square root 2 root 65, and I'm going to leave it as that because it's so much easier to write that and type that in than to make it a decimal. So that's 2 root 65. Oh, this was the question that Hamza was doing the other day. He did something really stupid on this question. I'll point that out when we get to that. Oh, in fact, we are at it now. Now we're looking at this triangle, EAC, and we have to label it HAO. And the thing that Hamza did wrong was that he labelled this as H instead of O, because he's silly. And he wondered why he was doing cos, and he was like, it's a math error when I use inverse cos of 2 point whatever. Yeah. That's because that was supposed to be O, and we're supposed to use tan. So tan of theta, I'll call this theta, is opposite over adjacent. So I just need to untan that. Okay. 2 root 65 inverse tan 23.5-ish. Okay, I'll write out the whole answer because that's what you're supposed to do, and then I will round it. Aha. Good, I haven't done one of these cone on top of a cylinder questions in at least a day. On this diagram, all lengths are given in centimetres. A cylinder and a cone are joined together to make a solid. The cylinder has radius r and height r plus 5. The cone has radius r and slant height of 9r over 2. Show that the total surface area of the solid in centimetres squared is that. Right, let me just check the formula sheet. Right, so we have curved surface area of cone pi rl, curved surface area pi rl. What else do we have? Surface area of a cone, no, we have to work that out ourselves. Okay, fine. Okay, let's do the cone bit first. So that's going to be pi times r times 9r over 2. And then the cylinder is going to be, what is it? Is it, let me get this right. If you get a cylinder and then you unravel it, like that, so you take a cylinder, like this, and you unravel it. Then what was the circumference before? Once you've unravelled it, it's going to become the length. Circumference is pi times diameter. Okay. And the width of it is the like height. So that's r plus 5 that way. And it's just a rectangle. So the cylinder surface area is going to be pi times diameter. So that's pi times 2r times r plus 5. That's just the curved bit, but then there's also a circle on the bottom, so I'll add that on, pi r squared. I don't need to add this circle at the top because it's covered by the cone. Okay, so total surface area equals, we've got 2r, so that's r squared. Okay, so 9 pi over 2r squared plus, that's a 5, right? 2r squared pi. I'm changing around between whether I put pi before r or afterwards. Oh well. Plus 2 pi 5r plus pi r squared. Don't doesn't look much like that at the moment. Let's factorise why is this 9? Well, there's no 9 in here. That's concerning. Oh, these two are the same sort of thing, so I could combine those. So 9 over 2 is like 4.5. 4.5 plus 2 is 6.5. 6.5 is like... Oh, is that... I can add that one on as well. That's also a pi r squared. Okay, so I've got 4.5 pi r squared. I've got 2 pi r squared, and I've got another 1 pi r squared. So altogether that's 7.5. Yeah, 7.5, which is 15 over 2 pi r squareds. And then I've got a 2 pi... Oh, 2 times 5 is 10. Okay, I've got a 10 pi r. Okay, so now let's factorise 5 over 2 pi r on the outside, just because that's what they did. I'll check what I've got left. Okay, so that's going to become 3. I've still got an r. Right, I'm going to have to divide this by 5, which is 2. But I've got this fraction here, so I should make that 20 over 2. Yeah, so if I make the 10 into 20 over 2, that way when I take this 2 out, I'm dividing 20 by 5, which is 4. So then that's the answer that I wanted. That was just part A though. There's also a part B. The total surface area of the solid is 1200 pi. Work out the value of r. Okay, so what was it before? It was 5 pi r over 2, 3r plus 4. And that is apparently 1200 pi. Okay, let's just get rid of the pi. So divide both sides by pi. So that way we've just simplified matters a bit. I'm also going to double everything because I don't like fractions. Okay. Let's expand the bracket. Alright, and we've got a quadratic, so I need to make it equal 0 to solve it. Right. Shall I factorise that? I probably shouldn't. It's a calculator paper, so I should use the formula. Sorry, that was me yawning. I'm going to divide by 5, just for fun. Except I'm going to check that on calculator, because if I've divided by 5 wrong, that would ruin everything. That's fine. Okay. Yeah, I'm not going to factorise that. I'm going to use the formula. So r will equal minus 4 plus or minus square root of 4 squared minus 4 times 3 times minus 480, all divided by 2 times 3. Type that in. Equals 12. Or if I put minus in instead, probably going to give us a negative, so we're going to disregard it. Minus 40 over 3. Okay, so this would have factorised into... I wish I'd tried now, because that sounds like fun. 12 and 40. Yeah, because then 36. Yeah, that does work. Anyway, doesn't matter, it's so much easier on a calculator. Okay, I can discard that one because the radius can't be negative. But I should still write it down because it is still a solution to that equation. The answer is 12 centimetres. Wait, was it centimetres? What was it? Yeah, well, the radius is 12 centimetres, but the value of r is just 12, technically. The diagram shows a right-angled triangle. Prove algebraically that x to y equals 2 to 3. Nice. Okay, so let's use a bit of Pythag. 8x minus y squared equals 6x squared. Make sure you square that 6. X plus y squared. Okay, I'll expand all this out. By the way, I've got no idea how I'm going to end up with this at this point, just so you know. That's not how I approach questions. I don't look at that and think, if x to y is going to be a ratio of 2 to 3, then how am I going to... I'm not even thinking about that. I'm just like, oh, it's a right angle triangle. Let's do Pythagoras, because why not, you know? And that's the kind of way that you should be thinking. Like, you see a right angle triangle, you Pythagoras it. Who cares if it turns out it's irrelevant? It 99% of the time is exactly what you need to say. Right, I'm going to expand that out. Y squared, 36x squared plus x squared plus 2x plus y squared. I can take away y squared from both sides. I've got 37x. Let's take away 37x squared. What's that? 27. Get out, use a calculator. 64. Take away 37. It's 27. 27x squared. I've got minus 16xy. Take away 2xy. And is that all I've got? Got no... Oh, that's good. I can see how 2 and 3 is going to come into that. Because... I can almost see. Let's take the x out. Obviously x can't equal 0 here because that would be nonsensical, because that would mean that length is 0. So I can almost like just divide by x and say, yeah, forget x. And I get that equals 0. So 27x equals 18y. So 3x equals 2y. So x to y equals 2 to 3. Okay, to make this clearer, x equals 2/3 of y. And that's why x to y is 2 to 3. Are we on the last question? No, almost. Solve 16 sine squared x equals 1 between 0 and 270. Okay, let's start by dividing by 16. And then let's square root plus or minus 1 over 4. Okay, so I need to do the inverse sine, so x equals inverse sine of a quarter, or the inverse sine of negative a quarter. So let's see. Inverse sine of a quarter, give me 14.5 degrees, and I happen to know that the negative a quarter is going to give you negative 14.5 degrees. That is only true with sine and tan. With cos, like the inverse cos of a quarter and the inverse cos of negative a quarter are not going to be like plus or minus. The inverse cos of a negative number ends up being the same as the inverse cos of the positive number, because the symmetry of a cos graph is different from the symmetry of a sine graph. Sorry, I was just yawning as I was talking, so my voice probably sounded really weird then. I promise my voice is not breaking. I'm not going through male puberty right now. Okay, now I need to get the rest of the solutions. So 0 to 270, let's draw a sine graph. That's 180, that's 270. So 90, 180, 270. So one of the solutions is 14.5. Let's say that that's there. So by symmetry, I need to go 14.5 that way from 180. So I'm going to do 180 take away 14.5, which is 165.5. So 14.5, 165.5. But then I've also got, whoops, oh my gosh, I almost just spilled my glass of water like all over my desk. And that would have been really sad because I've got lots of important stuff on my desk, like all of your mock exam papers that I need to mark. So that would have been a disaster. Also, I would have damaged my extremely cute Eevee plushie, and that would have been even more of a disaster. Anyway, where was I? Minus 14.5. Okay, to draw that I'm going to have to go backwards a little bit. Now minus 14.5 you're not actually allowed because it's not between 0 and 270. But I still have to think about it because it is going to give us another solution over there, which is allowed because it is in the range. So I can see that that's 14.5 to the right of 180, so that's going to be 194.5. So don't just disregard that one, just be like, no, don't need that one, it's negative, doesn't count, because you do need it to work out the next one. Right, final question. The curve y equals f of x has dy by dx equals kx, x minus 3 cubed, where k is a negative constant, that's in bold for us. There is a stationary point at x equals 3. Determine the nature of this stationary point. You must show your working. Okay. If there's a stationary point at x equals 3, that means that the gradient, at the point x equals 3 has to equal 0. So if I put 3 in place of x, it has to equal 0. Yeah, which it does. Sorry, for some reason I thought I was like trying to find k. Well, no, you can't find k from that because 3 take away 3 is 0, and yeah, that wasn't helpful. Oh well. Anyway, I'm only determining the nature of the stationary point. So what I have to do is do the thing where I say, right, x equals 3. I'm going to go a little bit before, so let's say 2.9, and a little bit after, 3.1, and I just need to find out what's the gradient like over there. So if I put 2.9 into dy by dx, okay, I can't actually work this out because of this k, but all I need to do is work out, is it positive or negative? 2.9 take away 3, that's going to be negative. And when you cube a negative, it stays negative. And then k is a negative constant, so I've got negative times negative, so that's actually positive. But it says you must show your working, so let me just put, because 2.9 minus 3 is negative, and k is negative. Negative times negative equals positive. There we go. So when x is 3.1, I got k times 3.1 times 3.1 minus 3 cubed. Okay, that's going to be positive. Positive cubed is still positive. Times by negative is going to be negative. Okay, so 3.1 minus 3 is positive, k is negative, positive times negative is negative. Right, so it goes, gradient is positive, then the gradient is 0, then the gradient is negative. So it's that kind of shape, so it is a maximum point. Okay. And, oh yeah, it says right there, end of questions. Okay, I will see you next time for another walking talking mock. Don't forget to like this video. No, okay, I'm not going to bother doing that. See ya.